Let's talk about vectors in two dimensions. We can use the familiar xy coordinate plane to decompose vectors in two dimensions. This is very useful in solving problems in physics, where we often use decomposing the vector into its components. This process can be thought of as finding the vector's shadow on the principal axes. Now, let's put vector A in the xy plane so that its tail is at the origin of the coordinate system. Then the head of vector A will be at some point O in the plane. Notice that point O has coordinates which are projections or shadows of point O on x and y axes. Components of vector A, which are vector A of x and vector A of y, are projections or shadows of vector A on x and y axes. It can be seen that vector A of x and A of y add to equal vector A using the law of vector addition. Using the Pythagorean theorem, we can obtain an expression for the magnitude of a vector in terms of its components. The vector A is the hypotenuse of a right triangle whose legs are vectors A of x and A of y. Hence, the length of the vector A is given by the following expression. It is often useful to have a shorthand notation to specify directions. That is why we introduce unit vectors. Unit vectors are always pointing in the direction of the positive axis. They have magnitude of 1 and only specify direction. The unit vector in x direction is x roof or hat, and the unit vector in y direction is y roof or hat. In three-dimensional space, we have one more unit vector, z roof, in z direction. Other vectors can be specified by using unit vectors. In our example, we can write vector A of x as a product of magnitude of vector A of x and unit vector x roof. And vector A of y can be specified as a product of magnitude of A of y and unit vector y roof. With these two expressions, we can rewrite vector A in terms of two components, as in following example. Let's do an example of resolving a vector in two dimensions. We have a vector A in xy coordinate plane. Projections of vector A on x and y axes are vector A of x and A of y. We can see that these two projection vectors add to vector A. Now let's introduce unit vectors. We can see that 4 x roof unit vectors add to vector A of x, and 2 y roof unit vectors add to vector A of y. Using equations above, we can write vector A as in following expression. It is clear that every vector in xy plane can be specified in terms of real numbers multiplied by unit vectors. We calculate the magnitude of vector A using the Pythagorean theorem as in following expression. Now, let's add two vectors in xy plane. We have a vector B. Projection of vector B on x-axis is 2 minus x roof vectors, and on y-axis 3 minus y roof vectors. We have minus sign because we can specify vector B only in terms of inverse unit vectors which have minus sign, or we can just say that vector B is in negative section of x and y axes. Let vector A be specified with 4 x roof vectors and 2 y roof vectors. We can add vector b to vector a by using geometric construction. Shift vector b parallel to itself until its tail is at the head of vector a. The vector sum a plus b is a vector c drawn from the tail of a to the head of b. Now we can write vector c as two x roof vectors minus one y roof vector. Also, we can add vectors a and b by adding their components, like this. By solving this equation, we get the same result as with geometric construction.